Today I'm going to cover the basics of sound waves. Over on the right of the presentation, I've got some really good links for you to try. So as you're going through, stop and look at them. Um, but we should start with some catchy titles. So I've got sound advice. Anybody got any other ideas? Sound ideas. Excellent. Sounds good to me. And that's enough terrible puns. So first thing out of the can is that sound needs a medium. It can be a solid, a liquid, or a gas, but sound cannot travel through a vacuum because sound needs something to vibrate. So have a look at there's an animation and then there's an actual experiment with the bell inside a vacuum jar for you to look at over there. But let's just put sound needs a medium. It cannot travel through empty space. Because a notable wave that can travel through empty space is light. And actually, the Victorians really worried about this because they thought, hang on a minute, what is vibrating if light is a wave? What is it that's oscillating? Everything that vibrates makes a wave. Okay, yeah, so, but what is it with light if light is traveling through space? Anyway, we'll come on to that another time. Now, if I draw a picture of a sound wave, then it goes up and down like this. And this might be time or position. We've seen that before. And if this was displayed on an oscilloscope, a cathode ray oscilloscope, also known as a crow, then what we do is we play the sound into a microphone, and the cathode ray oscilloscope would change the display into a voltage against time display. And we can see, again, if we look at this link, we can see that if you increase the amplitude, you can remember what amplitude is, I hope. If you increase the amplitude, then the sound gets louder. If you decrease the period, then the pitch gets higher. That's a very high note. So just to remind ourselves that on our picture, this is the amplitude, which I'll call A, and this is the period. It's the time for one complete wave. So there you have it. Now there's one other thing that can happen with the wave, and that is its shape can change. And if you think about it, you can play middle C on a piano, and then you can play middle C on a flute, and a piano sounds different from a flute. And yet they're both middle C. So they both have the same pitch, so they both have the same frequency. So basically they go up and down in the same time. Pitch sounds different from a flute because the detail shape is different. Detailed shape. So this is how voice recognition software works. They can write, you can write a computer program that will recognize the shape of your sound waves produced by your vocal cords. And so they can tell who they are. So in the days of Saddam Hussein had about 25 different lookalikes, who stood in for him because he was so paranoid about being assassinated. But they could recognize which was the correct or the real Saddam Hussein by listening to his voice. Okay, so then we get up to number 4. What's going to happen with number 4? Coming up, number 4, range of audible hearing. Well, for humans, we usually say it goes from 20 hertz up to 20 kilohertz. 20 hertz is a very low frequency. 20 hertz, if you play 20 hertz into your loudspeakers, they probably won't like it much. It's as basso profundo as it gets. 50 hertz is the sound you get from what's called mains hum. The sound you get when you collect something to the mains, which oscillates at 50 hertz. Middle C is 256 hertz. So if we just say, well, that's roughly 250, then an octave above is 500, an octave above that is 1,000, an octave above that is 2,000, an octave above that is 4,000. Every time you go up an octave, you double the frequency. But hang on a minute. I think we've got up to 4,000 and we're going off the top of the piano after 4 octaves. So what's the point of being able to hear up to 20,000 hertz? Well, the answer is contained in part 3. If this is your sound wave going up and down like this, then if you're playing something like piccolo, then it might have a little detail like this, and the frequency of the little detail might be as high as 20,000 hertz. So if you don't have that 20,000 hertz capability, then you won't hear what they call the brilliance. It'll sound a bit dull. Now, unfortunately, as you get older, unfortunately, the 20 kilohertz goes down. So I reckon I can do about 12 kilohertz now. So I can still listen to music, but I don't notice if music sounds dull anymore. Because people often say, well, dogs can hear above 20 kilohertz. So that's why dog whistles are so effective. They can respond to dog whistles. In my experience, when my mother had a dog whistle, I could hear it only too well. She couldn't hear it, but I could.